Hello everyone. So I made a very important realization the other day. I made the realization that my theory of quantum gravity is not pseudoscience. It is science properly. I'm doing proper science. The reason why I'm doing proper science is because the hypothesis that I've come up with concerning gravity is testable. It's possible to prove wrong, and I'm going to go into the way in which it's possible to prove this idea wrong as this video unfolds, but I think I'll give you first a quick rundown as to what my theory of quantum gravity entails. So it entails this notion that all objects with mass, or rather all objects made of atoms, have a probability density of electrons surrounding those objects, and that probability density of electrons is equivalent to the gravitational field, or it is the gravitational field, I should say, of the object to which it belongs. And this probability density of electrons diminishes in terms of its content of electrons. The further away from the surface you get, it diminishes in accordance with Newton's inverse square law of gravity. So objects falling into this cloud of electrons, this gravitational field, the electrons in the gravitational field are attracted to the protons in the approaching object, and they exert a force of attraction over the protons in the approaching object, and hence the object itself. And the object will hence have its trajectory around the first object augmented to some extent by the gravitational influence of these gravitational electrons. So that's roughly speaking the idea that I was proposing, and the reason it's possible to disprove it is that one of the predictions of Einstein's theory of general relativity is that light having mass ought to also give off a force of attraction due to gravity. In my idea, my theory, my notion, whatever you want to call it, light would not exert a force of gravitational attraction. So this is one way in which you can start testing this hypothesis. You can say maybe do experiments, or very sensitive experiments in space or in vacua, whereby you have a very strong laser beam, say, and you have maybe a single atom trying to get this atom in orbit around the laser beam, or trying to measure the extent to which this atom is attracted to an extent via gravity, via the supposed gravity generated by the laser beam. That's how you would go about testing for this idea. So another way to test it, of course, is via neutrinos. And I've gone into this a little bit in the past, that this idea can be tested via trying to measure the extent to which stars, such as our sun, deflect neutrinos. I predict that they wouldn't be deflected to any great extent at all, really, that there would be no neutrino wind coming off the sun due to the supposed curvature of space-time around the sun, and that instead of this curvature of space-time, it's just a cloud of tunneling electrons comprising the gravitational field, and that's what quantum gravity is. So yeah, I'm not doing pseudoscience. I'm doing proper spare time science. I'm an independent researcher, or to coin a sort of very 19th century term even, a gentleman scientist. A gentleman scientist, typing away, just pulling that quantum gravity thread in my spare time and doing real science. I love it, fantastic. So yeah, this is just a brief video about how to test my theory of quantum gravity, and I thought I would end it there and just keep it brief for today. Thank you very much for watching. Bye bye, love you lots.